Hello, this is the second video of the fourth calculus series on integration techniques for OCR Pure Core Further Mathematics. And we will integrate using tan x. If we consider the integral here, we note that it is of form k over ax squared plus bx plus c, rather than the 1 over a squared plus x squared, which we already know the standard result for, this being 1 over a arctan, or tan to the minus 1, of x over a plus c. So as in the previous video, if we can transform the top integral into a form which allows us to use this known standard integral, we should be able to solve it. Using similar technique to the last video, let's consider that denominator, 5 plus 2x squared plus 2x. And initially I'm going to divide by 2, not forgetting to put that factor back in later on. That would give me 5 over 2 plus x squared plus x. Now I'm going to complete the square to give me 5 over 2 plus x plus a half squared minus a quarter. This will give me 9 over 4 plus x plus a half squared. This looks like it's in the right form of a squared plus x squared. So I'll have my integral with that top factor 5, and I'm not going to forget the fact that I've divided by 2, and I'm going to put those factors outside the integral. I could do that in 2 steps, leaving me with 1 over 9 over 4 plus x plus a half squared. At this stage, I note that my a will equal 3 over 2, because that 9 over 4 is the a squared. I could use the substitution u equals x plus a half, but I note that du by dx equals 1, so I'm not going to bother. I'm going to go straight for applying this standard integral, which the result will be, I have that 5 over 2, I need my 1 over a factor, which will be 2 over 3, and then I've got arc tan. Now the x will be x plus a half, and the 1 over a will be at 2/3. And then I mustn't forget my plus c. Tidying up that front fraction would just give me 5 over 3 arc tan 2/3 of x plus a half. So that's that, and then plus c. So the key thing to note in that first bit was to keep an eye on what I was aiming at, that a squared plus x squared form. On this slide they have used the substitution. So you can see here that's just become u squared and then the u term, and then we've just substituted back to get that x plus a half term in the final result. So in summary, we've dealt with an integral of the type 1 over ax squared plus bx plus c. We've taken out factors to give a numerator of 1 and a coefficient of 1 for x squared. I then completed the square of the remaining expression, again being careful with my signs. I substitute for the squared variable expression. However, you don't have to do that if you find that du by dx equals 1, and you will be really careful when thinking about what that x term will be. Then apply my standard integral, noting carefully what the a term will be by comparison. Once I have a result, I reverse the substitution, if I've used one, to get an expression back in the original variable, usually x. I note that items 3 and 5 may be omitted after practicing the technique, as long as du by dx equals 1. In the next video, we will integrate using substitution x equals sin u.